This movie discusses how we work with differential pairs in the Proteus Design Suite. The setup phase has two main parts. We start on the schematic by identifying the differential pair pins. This needs to be done both source and destination components. If there is more than one differential pair on a component, then they are added with a semicolon separator. The other thing we need to do on the schematic is give each differential pair a name. We do this by placing a label on one of the wires and then creating the new differential pair from the resulting dialog form. We now need to set up a net class and design rules for the differential pair. This can be done either on the schematic or, more normally, at the start of the layout development. From the Net Class tab, we create new class and specify track width for routing the pair. It can also be useful to change the rat nest color so that you can more easily identify them on the board. We then switch the Differential Pair tab and associate the net class with our pair. In the case where you have multiple pairs, the same net class can be assigned to each one. There are some extra fields here for us to fill out. The phase shift field specifies the maximum allowable difference in the two track lengths before we add serpentines to equalize. The other fields relate to the separation of the two tracks and how much that is allowed to change. More information on each option is provided in the help. The last place we need to do some setup work is in the Design Rules tab. It is quite common to set up some clearances between the differential pair and everything else. We do this by applying the rule to the net class we've created with respect to all other net classes. Finally, we are ready to route the differential pair. In the basic case, we can simply select the diff pair routing mode and click on one of the pins. Proteus will automatically fan out from both pins and we can continue routing towards the destination. For curved routing, simply hold the control button down as you route the pair. We finish the diff pair by clicking on the destination pad. In the more normal case, where a fan-out or vires are involved, we need to manually route the entry and exit using normal track mode. Then we can switch to diff pair mode and pick up the route by clicking one of the tracks or vires and routing as before. In extreme cases, we can also route entirely in manual mode, hugging the second route to the first to maintain the correct clearances. Regardless of how the diff pair is routed, Proteus will detect when it is completed and the lengths of the two tracks that are equalized by the addition of small serpentine sections after corners. Note that this phase matching or screw correction depends on the direction you have routed it. If you have routed from receiver to source, you need to reverse the route directions from the context menu, which will then trigger the correct phase matching. Finally, if you need to edit the diff pairs, remember that you should phase match again from the context menu when you are finished. Differential pairs can easily be matched to target length. First, go to the Length Tuning dialog and set the style and size of any length matching serpentine segments. Then from the Design Rule Manager, set an appropriate length matching tolerance for the diff pair. Finally, use the Input Target Length command on the context menu to lengthen the diff pair tracks to the target distance. You can also match lengths with other differential pairs by selecting one track from each pair and then using the Match Lengths command. If needed, length match serpentine segments can be dragged along the differential pair into their ideal position. All differential pairs are checked compliant in the pre-production checker, and a differential pair report is available in Project Notes, which lists relevant tolerances and compliance status. You can also visualize the phase from a context menu command on the route. Green segments are in phase, yellow segments are skewed but still inside phase tolerance, and red segments are skewed beyond the phase tolerance. Corrective serpentines act to equalize the lengths again after we drift out of tolerance.